All right, of course, the last part of this unit before the test has to be word problems. So day 7 is quadratics and context. Next class after this one will be review and then test after that. All right, this page is very important. This just kind of breaks down what we've been talking about this whole time of the different forms of equation you can get and then how you pull the information through that. So if I ask you for the x-intercepts, you have to, if it's in standard form, you have to factor and solve. If it's in vertex form, you can only find it through graphing. If I give you a vertex, if I'm asking for the vertex or the maximum or minimum point, in standard form, you have to use this equation, opposite of b over 2a. If it's in vertex form, you just figure out what h and k are. And then your y-intercept, in standard form, it's always your constant, your c value. For vertex form, the easiest way to find that is just to plug 0 in for x, and then your answer will be your y-intercept. So over on the side under example 1, I have sketch, define what they're asking for, and then answer in context. So the best way to go through these problems is to first read them, kind of draw a little picture of what's happening, and then decide what parts they're asking for. So it says the Tacoma Narrows Bridge in Washington has 2 towers that each rise 307 feet. So I'm going to draw the bridge over here. They are connected by suspension cables. The path of the cables can be modeled by that quadratic. So it says from the top, which is 307 feet, there's a cable that goes like this. So I know that this is 307 feet tall. Wow. Whoops. All right. So there's kind of my sketch of seeing what's happening. They want to know what is the height of the cable at its lowest point. So here they're asking for our minimum, which we know is our vertex. And they want to know what is the distance between the 2 towers. So this kind of goes along with something we haven't really talked about. So again, they want to know what is the lowest point, so our vertex. And we also know just by common sense, our use of physics, and the way things work in the real world, I know that the distance from my vertex to this tower is going to be the exact same as the distance from my vertex to this tower. So once I figure out where my vertex is, I can figure out how far away the 2 towers are. One thing I'm going to notice is that this is in standard form. So we have to use, to find our lowest point, our vertex, we need to use x equals the opposite of b all over 2a. So I have a, b, and c is 1 over 7,000, negative 2/5, and 307. So I'm going to do 2/5 divided by 2 times 1 over 7,000. Because there's fractions within fractions, the best way to do this is to write both of these as decimals. So I know is 0.000285571, and the top is just 0.4. So the x value of my vertex is 1,400.21, and this is in feet. So to find the y value, to find the actual lowest point, I have to take that and plug it into the equation. So I'm just writing all of this And then the best thing to do is pick up an actual scientific calculator and just plug this all in at once, since these numbers are going to be so ugly. So when I plug all of that into a calculator, I get that 1,400 feet from the first pole, the cable hangs 27 feet off the ground. So my vertex is the point 1400.021, comma 27. And that's rounded, but there's just so many zeros that it doesn't really matter. All right, so we can answer the first question saying the lowest part of the cable is 27 feet high. Okay, our vertex also gave us some other really big information. So since the x value is 1,400, that tells me that from this cable here to the midway point, that's 1,400. So to see how far the other cable is, well, that's just going to double. So that's going to be about, so I can say the cables are about, sorry, not cables, the towers are about 2,800 feet apart. Because that's going to be my full distance all the way across. So I know that problem's super ugly, lots of fractions, but hopefully some of the questions and process to find it made sense. All right, scenario B has Angry Birds. So again, you want to sketch, try and figure out what they're asking for, and then answer your questions in context. So scenario B, you're playing Angry Birds and attempting to knock out all the pigs on the other side. The Angry Bird follows the path g of x equals negative parentheses x minus 5 squared plus 25, where x is the distance in feet and g of x is the height. So it wants to know what is the maximum height of the Angry Bird. And then if the pigs are set up 9 feet away, what is the height of the Angry Bird when he reaches them? So again, height is going to be your y value. So if they want maximum height, that's the y value of the vertex. And they want to know what your y value is when x equals 9. So those are the two separate questions they're asking you. This equation has parentheses in it, so I know it's vertex form. So I need to find the y value of my vertex and then also evaluate the equation when x equals 9. Because it's in standard form, I know that the vertex is 5 and 25. So I can say the maximum height of the Angry Bird is 25 feet. And then it asks me if the pigs are set up 9 feet away, so if it travels a distance of 9 feet, how high is the Angry Bird off the ground? So this is just asking me to take 9 and evaluate that into the equation. You can plug this all in the calculator at once or simplify it by hand. I'm going to do parentheses first. So that will be 9 minus 5 is 4. And then exponents, so that's negative 16. And then negative 16 plus 25 is 9. So when the bird reaches the pigs, it is 9 feet off the ground. So again, I should have drawn a picture first. So the Angry Bird is here. He's getting shot into the pigs, which are somewhere over here. We say that the pigs are set up 9 feet away. It's a terrible pig. So again, they want to know the maximum height, so that's the vertex. They want to know how high they are when they hit the pigs, which is 9 feet from when they were launched. So those are all the different points we were finding. So you have one scenario to try on your own. So again, sketch a picture of what's happening, look what they're asking for, and then answer in context. Since your equation is negative 16t squared plus 200t plus 50, this is standard form. So to find the vertex, you have to use x equals opposite of b over 2a. We're talking about a toy rocket being launched in the air from the top of a building that's already 50 feet tall. So there's the building, and it's being launched into the air, and then gravity brings it back down. They want to know the maximum height of the rocket, so that's the y value of the vertex. They want to know at what time will the rocket reach that height, so that's the x value of the vertex. And then explain what the y-intercept represents in this scenario. So they're not asking you what is the y-intercept, they're just saying what does it represent. So your y-intercept, remember, is the start of the scenario. So good luck finding those things. Really, you just need to find your vertex and then explain what your y-intercept is.